Cheers, Alessandro. Welcome, everyone, to Innovation Coffee here on the ARM Software Developers YouTube channel. Today, we have an amazing episode for you. We're joined by Andre Workington, one of our ARM innovators, who's going to be talking to us about a recent release from VMware, VMware Fling, ESXi on ARM. So for all of you developers out there who have, my Twitter feed was full of all of this cool stuff happening with ESXi on ARM. For all of you developers out there who are interested in this topic, I'm sure you are in for a treat with Andre Workington, who's going to be sharing all sorts of cool stuff with you. Also, keep in mind that everything we talk about in this episode, links, resources, all provided in the description below after we finish the live stream. Questions in the chat, we take them. So post in the chat, we'll bring them to our guest, Andre Workington, and we'll get all that stuff answered. Now, before we bring him in, Alessandro, you have an update, right? Because we had an episode last week, and we do like to talk about what we did last week. So maybe we can do a recap.
Yeah, thank you, Robert. Welcome, everyone. So we had a really cool episode last week. We talked about TinyML with one of the really interesting companies in this space called Cartesium AI. And we talked about how it's really possible to do machine learning on really tiny devices. And we actually saw a bunch of demos. The two founders of Cartesium came on, and they gave us an introduction to what Cartesium can do and the different things they're seeing in the market, the different trends they're seeing in the market. And then we had a demo from them, and one from one of our engineers actually that showcased a really cool demo on Cortex M23, so the kind of successor of the M0. So really, really low power core running machine learning on the device, and not just that, but actually training on device. So it was super exciting. It was fun, and we're gonna have a nice cool video that will be accompanying that, or with a demo coming up soon as well. So check that out soon.
Yeah, that was an awesome episode last week. I mean, we had it was Joel, the CEO. There were some engineers on the call. CTO was there, so there was some good discussions. There was some a good demo, as Alessandro mentioned, two demos actually, and I definitely recommend, if you have an extra hour in your day or your week, cruise on over to the channel and check that last video out. So thanks for the recap there, Alessandro. Should we bring Andre in now? Is it time?
It's time.
All right. So Andre Workington, we're going to bring him into the call. Andre is the ARM enablement architect at VMware, and he has done a lot of work with ESXi on ARM. So Andre, how you doing? Welcome.
I'm doing fantastic, Robert. Thanks for having me.
Welcome, Andre.
Did you bring coffee with you, or?
I brought a little bit. There's some remaining.
Okay. Whatever's left. Cheers. So, Andre, as we usually do on this show, we do like to spend some time getting to know you before we dive into the tech goodies. So, if you wouldn't mind just kind of giving us your spiel, your origin story.
My origin story? That's a good question. So, I've been at VMware for quite a bit of time now. So, probably the longest I've been. Well, definitely the longest I've been anywhere, including school. So, this is my 9th year. And I spent most of that time actually working on ARM and virtualization. Before that, I worked a little bit on storage technologies like NFS or NASs and SANs. And before that, I actually was a Motorola working on the world's first Android tablet. That was a Moto Zoom. And before that, I worked in Hyper-V and Microsoft. So, yeah.
I didn't know you worked at Motorola. That was, I think, my first cell phone, or was it? I think Motorola was my first cell phone, then a Nokia. But so yeah, Motorola,
I mean, my shortest stint, because the company then renamed itself to Motorola Mobility as a split, basically. So
gotcha. Maybe one day when we meet in person, I'll pick your brain on your time at Motorola, because I like diving into the past there. Yeah. So yeah, awesome. Nice to get to know you. I hope everyone viewing got to get to know you as well. Andre is a legend.
Oh, yeah. David's being a little too nice to me. Honestly, I've always aspired to work in operating systems, and as a teenager, I was like, oh yeah, I want to write my own operating system. And I used to hang out on some forums, and there was the Usenet group and all that. But honestly, I didn't have enough neurons to do anything beyond just like a simple hello world, and I would sit there like polishing or like something, but it didn't actually ever write an operating system, right? And like there are people out there who can do stuff like this when they're 12. They are out there. They exist. Like there's this one kid I know that not only did he write his own operating system, he wrote his own JVM, right? And he was like 15 or something. So these people exist. So I always wanted to be a kind of an OS guy, and so I guess that kind of shaped my career.
Yeah, I mean, not only, I mean, I'm impressed, Andre, but you know, your mention of not only do these young developers exist, we actually have a frequent community member who joins this call, Arjit Das, who's in the call right now. Hey. He is with us all the time, and he's a 14-year-old who is doing amazing stuff with TinyML. So yeah, I know. Cheers to Arjit. I promised him that one day we'll share his Discord channel. He has a cool little community going on there, and kudos to Arjit.
Sweet.
Yeah. So let's dive in. I think you know, as I mentioned before the call in our green room, I want to build this foundation. So the viewers who are watching this, right? Like I know a lot of you will know what VMware, a lot of you know what ESXi is, and all this cool stuff. But I want Andre to tell us. So we're gonna start from the foundation. What is VMware? And let's not spend too much time, but let's build that.
So maybe we should do a Twitter stuff. Say, VMware wrong answers only. VMware, okay. But VMware, many people remember VMware as the x86 virtualization company, right? But we actually had a few paradigm shifts over the years. And at some point, we became just a virtualization company, really. And then it was more about, well, now we have, okay, so first we really were an x86 emulation company, okay? And then was x86 virtualization company. And we brought on these network virtualization and storage virtualization products. So you could say it was just virtualization, right? But of course, then we broadened our scope, and that was just infrastructure, right? So because we don't just run VMs or virtualize your network overlay, well, now we run containers, right? Now we have a story for actually disaggregating, let's say, our hypervisor and letting you run bare metal workloads on servers, right? So we're no longer a virtualization company. We are an infrastructure company. We are there in your data centers, or hopefully soon at your edge, trying to make your operations simpler. That's all it's all about. I feel like I'm the only person. Oh, there we go. There you are.
No, it's funny because so Andre, thank you for sharing. You know, when we do those big screen, we solo layout you. I try to get in little promotions on the side, right? Like posting something on Facebook.
Okay, am I alone? No. Okay.
Yeah, no, you're not alone. Cool. So that's a good explanation for VMware. And now let's build on this. A long time ago, there was something called ESX. And I think now people are familiar with the more commonly used term ESXi. So what is ESX, or what was ESX, and how did this turn into what we now know as ESXi?
Oh, that's a great question, right? So maybe let's just unwind completely back, and let's say, what did VMware start with? It started with VMware Workstation, right? The Workstation was virtualization in your favorite OS. There was Windows, there was Linux. Okay. So then at some point, some bright bulb at VMware decided, well, why couldn't you run these VMs headless? Like, wouldn't it be great to do this to a server, right? And so there was another product which nobody talks about because it's long dead, called GSX, which was basically a headless workstation, okay? And then another bright bulb at the company realized that, well, it's not particularly efficient. We know we could be doing much better. And so at some point, basically, the virtualization layer kind of grew to be its own kernel, right? And this kernel started doing more and more things. At some point, it had its own I/O stack. At some point, it was basically, it was obviously scheduling the VMs, but it was taking more and more functions in order to do these functions as in a most optimized fashion. And so at some point, right, the only control, there was still this host OS thing, but it wasn't a host OS anymore. It became known as the console OS. So ESX was a product where the control plane for the system was still running in this console OS, which was a Linux VM. And that was ESX. Now, at some point, ESXi appeared, which basically moved the remaining control plane functions as user processes within the VMware operating system, and the console OS disappeared, and that was ESXi.
I'm not sure how many people. I was going to jump in and ask a really silly question. I always find it interesting when people name things with weird acronyms. And I mean, ARM is a weird acronym as well. So or it started off like that. So how did this name come about? ESX and then ESXi?
ESX, I believe, again, don't quote on me, right? We have a whole PR department before this. I believe it stands for something like Elastic Sky X. The 2000s were, names like that were really hot, but I think it's Elastic Sky X. And why Elastic Sky X? I have no clue. Now, ESXi actually started this whole notion of the console OS less variant. It was initially, I think, known as the embedded ESXi, or embedded hypervisor. And the reason for that is that they were, I think, the first product where it appeared actually in Flash, right? So you weren't installing it; it just came with the box. So yeah, it's pretty interesting how that kind of evolved just to be a general purpose OS hypervisor you can install in any system.
Yeah, I was looking it up. The I stands for integrated. So yeah,
That's my narrative.
Integrated. Yeah. So cool. So good to know where this all started. Now let's dive into ARM. ESXi on ARM. This was a big announcement, right? During, I think, it happened, from what I remember, it was around Dev Summit. So, we had you on a call during one of our post-game broadcasts, and, it was all announced during Dev Summit, or at least around Dev Summit. And the ESXi on ARM, I'm curious. So what is ESXi on ARM? And, why is this important to ARM developers or people who are using ARM, which is pretty much, I think, everyone at this point?
I think it's a pretty good question. So maybe let's take it back a few years, where at our trade show, VMworld in 2018, we first kind of gave a glimpse that VMware was in fact working on porting. So ESXi, of course, I don't think I mentioned what it is. ESXi is an enterprise-grade hypervisor, traditionally for your servers in your data center. So that's what it is, right? And we made a glimpse that ESXi is being ported to ARM, and the reason why it was being ported to ARM was VMware going to the edge. So it's this idea that compute would no longer be centralized in data centers or clouds, but it would become basically more geographically spread out. Inherently closer to where data is produced or consumed, right? So you could be talking about factory floors, oil rigs. Because in fact, right, one of the earlier narratives was that, just industry narratives, was that everything should go to the cloud. Well, that's great, but then your sensors can't just keep sending data to the cloud. That model doesn't obviously scale very well due to bandwidth issues, latency. And so clearly at some point the industry did realize that, well, clouds are great for many things, but if you want to be able to process tons of data, make decisions on the spot, well, you better do that closer to where the data is produced, right? And also alternatively where the data is consumed. So that's where we kind of first demonstrated ESXi and ARM, and we had this demo around wind turbines where it's an environment where something goes down, it's bad because maybe there's a mission critical workload, maybe it's like monitoring that the thing doesn't catch on fire, and if it were to go down, it's hard to reach. How would you do maintenance? So this is where we talked about one of the features that we have called fault tolerance, which is this notion that you could have two nodes, and the VM appears to run on both, right? But if one of the nodes dies or crashes or whatever, the VM continues running on the other host, right? So this is a pretty powerful technology because, well, first of all, it handles failure, right? Which you're not putting like 10 VMs into one box and that box goes down and you're out. No, but it also allows for kind of easy maintenance without bringing down services, because you can go maintenance on one machine, right? Do maintenance on another machine while the workload is still running, okay? And so that was our we talked about it first in 2018. In 2019, we did another glimpse of ESXi and ARM, but now on something completely crazy, SmartNICs, right? And we kind of demonstrate that, we're looking at this space, it's interesting to us, what on earth could we possibly do with it? In 2020, of course, we did this double whammy where we first announced Project Monterey, which is an actual concrete product being built with ESXi and ARM and with SmartNICs. The idea that we're basically reinventing what servers, from Dell, from HP, from Lenovo are going to look like, right? And we're also again bringing the values, the value proposition for our software stack, even to bare metal workloads. Like you don't have to run ESX on the x86 cores. Okay, you can do whatever you want, but you don't have to toss out vSAN and SX, because all those things will be running on the SmartNIC. But of course, it also lets you do other cool things like, well, let's say I want to be in the business of loaning hardware out to people. It's a business. People do that, right? Bare metal workloads. But then I want to kind of isolate them. I don't want them to really know about how my storage works or how my networking works. Again, this lets you do that. The I/O and the storage stack lives on this card. So I could call this disaggregating the hypervisor, where you can see it goes way beyond just, it goes way beyond ESXi on x86, cooperating with this thing. You could replace ESXi with anything else. And of course, the other thing on top of that, a week later or 2 weeks later, what it was, right at the new ARM event, the Dev Summit, we announced the Fling. And the Fling, it really is different. My Project Monterey is a very concrete, here we go. We're using this base technology we've developed to go do something cool. The Fling is basically a non-committal technical preview of ESXi ARM as the actual hypervisor that you could run on anything, right? Now, we've been working on the Fling for quite a bit of time, and the biggest question we had to answer is, well, if we put this out there, could people actually use it? Like, would it just be this weird download that nobody will click on because, like, ARM server, where do I go get out? But we put this tech preview out, and it's out there because we want to understand how either our customers or your customers or other people around the world, how they could find this technology useful in the data center, at the edge, in the cloud, right? ESXi and ARM Fling is not a product, right? And it's not even a promise of a product, but we're doing this to drive further productization.
I love the fact that you're kind of covering, with all the amazing software you're building at VMware, you're covering like the full spectrum, right? And you're in the best position to kind of, similarly to us, I guess, you're kind of looking at the whole world of developers, right? That from the cloud all the way down to like, things like Raspberry Pis, like embedded developer platforms, or in general embedded systems, right? And it's super interesting. I want to ask you a question, a basic question, right? That some of the viewers might be interested in, around the difference between virtual machines and containers, and what you think is the value of one over the other. Given that some of the aspects that you mentioned are covered also, or utilized in containers as well.
Yeah, well, I think it's a good question. So of course, when you look at VMs, they abstract at the hardware level, right? So yeah, you're creating new virtual machines, right? And then you basically don't care what goes inside of them. Okay, so if you wanted to run different kinds of operating systems, sure, that VMs are pretty clear. Now with containers, I think it's pretty interesting because there's really two notions there, at least in my view. One notion is, well, sometimes if you're just running more instances of the same thing, pretty much, right, then why on earth would you subject yourself to the overhead required by modeling an entire virtual machine and then running a whole separate operating system kernel within that? So from that perspective, containers are really, they're a thinned out abstraction that's abstracting at the kernel level, at the system call level, right? So that's nice. Another aspect of containers, which I think is even more important, really containers are, to me, a packaging technology. It's like, how do you package software? How do you package software in a way where, to track dependencies, basically, and to really be able to deploy a bit of software in a way where you can be sure you've isolated it well from from other bits of software. We all remember DLL hell, right? From a certain operating system, and DLL hell, well, it exists in other operating systems as well. And for example, it led to some of the Linux vendors to come up with interesting novel approaches to installing and layering software, which basically amount to using containers. So inherently, I don't think it's VMs versus containers, to be honest. And I think there is a sweet kind of middle between using hardware virtualization to isolate containers better, right? And that is basically what the VMware story for containers are. We have a story for running containers efficiently, with all the benefits that you get with containers and with the least amount of the overheads that you usually see with VMs. So yeah.
Did that answer your question, Alessandro? Yeah, no, I think that's actually a great point. I mean, I think I've heard this question asked to me several times. I've seen it in the community asked, the difference between containers and virtual machines. So I think it's noted here on the show. I want to kind of go back real quick into.
Sorry, Robert. I really just wanted to add a few more things about containers.
Oh, please, of course.
Really few. And again, I don't pretend to be a single source of truth. These are really just my opinions. One notion that I always thought that I was never quite too comfortable with is that what if my software stack really does depend on a certain kernel version? Okay, when we say containers, let's just assume we're talking about Linux containers. I mean, obviously other operating systems have similar technologies, but let's just say we're talking about Linux, because that is, at least in the context of ARM, that is just the de facto or default OS that we're all talking about. I and maybe somebody in the community can answer this, but like, how would you accommodate differences, any possible differences in ABI, right? Or a system call interface, right? If you have a bit of software that depends on a particular kernel version, right? Newer or older, right? It kind of means containers are not a good fit here. The other one is that some software stacks like to deploy their own containers, and I've seen collisions between that. You can't nest containers. So, do you let basically like two different foreign stacks create their own containers on the same host? Like, is that another variant of DLL hell? I personally don't know, but these are my concerns personally that would make me stay away from containers in some situations.
Yeah, I mean, also, I feel like containers, it's not one or the other. When you're talking about VMware and containers, I mean, like, you could spin up an instance, you could spin up your ESXi instance and still, in a way, use containers. So, I mean, like, I don't.
No, that's kind of what I'm saying, right? Is that perhaps this is where this marriage is. Like, maybe if you need like Linux 5 versus like Linux 4.9 for some application that's only certified by the vendor to work with a particular kernel version, right? It's trivial. You spin up a very thin, lightweight container host with one version or the other version, right? And then the containers go in the right places, right? But you don't have to chuck virtualization out the window. You can still use it to deal with these few corner scenarios where containers are difficult to use, right? Because they are inherently bound to the kernel version, right? For the system that they're running on. But I think that, nevertheless, I think they're a great solution to the packaging problem.
Nice.
Can I just make a comment? No, I was just going to say, I like your answer, because I think the reason for asking is I find sometimes that there is some confusion around it, right? And I like the fact that as the technology evolves and matures, I talk about like the whole containers and VMs are evolving a lot in the recent years. Actually, you could see like the evolution of the combination of the two, right? Like, not just, you don't have to choose, basically, as you said, right? You can choose to I mean, it makes sense to use some in one case, some in another, and it makes sense to use the combination of containers and virtual machines when you're trying to isolate and actually, as you said, spin up like a different type of operating system, perhaps for different types of applications.
Yeah. And just to be clear, I don't think virtualization is the only way to solve the problem of the syscall or ABI dependency. Maybe combining it with some bits of UML or like NetBSD rump kernels could be a solution where basically you're able to run whatever kernel you want inside the container somehow. So, yeah.
Nice. Okay. So I think we covered that. I want to go back to the Fling, the ARM, the ESXi ARM Fling. And VMware kind of has their own little section of the website where they have these ARM Flings. It's a thing that you all do. And I mean, this is also going to lead into this question from iShotJR in the chat. But ARM Flings, like I'm still trying to kind of, I guess, wrap my head around it. I'm sorry, ARM Flings, VMware Flings. I'm trying to kind of wrap my head around it. This is VMware saying, here's something we built, try it out, give us feedback. I'm from a developer point of view. So like I'm consuming one of your Flings, and what are you expecting from me as a developer?
Okay, so
kind of touched on it, but I want to elaborate a little further. Sorry.
Yeah, no, that makes sense. So the Fling is a mechanism for kind of doing a drive-by of new technologies, right, with our customers. And to be honest, nobody has ever flung an entire operating system. That has never happened. Usually, it's net new development. It's something fairly small, right? It's usually something that's complementary to the software stack that we have. Right now with ESXi ARM, right? Well, that's an entire hypervisor. Okay, I mean, yeah, sure, it's complementary in general to maybe the data center control plane that we have, but it is an operating system, and we've never done that. And that was actually one of the reasons why it took a bit of time. Is that on the one hand, we use the Fling as this mechanism, right, to go and request feedback. Now, what does that mean? It means that you try it out, and well, you let us know, like, oh, look, and you can let us, I mean, it's not even a direct channel. It's not as if like, oh, well, if nobody writes an email to VMware saying how great this is, well, maybe they'll never productize it. I mean, but it's also like, we see it, as people take it, they post things, they build awesome things. Like one guy who does actually work with VMware, but he's not affiliated with our group at all. He does robotics, and he built this robot where basically the brains of the robot were running in a VM on the Raspberry Pi, and he was actually live migrating the brains from one Raspberry Pi to another Raspberry Pi. That's kind of cool, and the robot, didn't like crash into a wall, so that's impressive. Okay, we saw that people in the FreeBSD community really latched on to ESXi and ARM because it allowed them to be more efficient around basically building and testing FreeBSD in ARM. Which, by the way, I thought it's kind of a surprising outcome to me personally, because virtualization of ARM is not exactly new. It isn't, right? I mean, it's been around. Obviously, KVM is the de facto hypervisor there, right? So the fact that, like, well, what's so special about ESXi and ARM? But I guess these folks found it was a lower barrier to entry. Fine, okay, so that's an interesting outcome. So we see these outcomes. People post things, they showcase different things. I mean, and of course, this interest does come back to us using our technical account managers and salespeople and all that. But it's a tech preview. You get it now. Don't run your business on it. It will probably not burn your house down, but it might eat your homework. That sort of thing. And again, you are running basically alpha grade software, right? We give 180 days for evaluation purposes. Obviously, you can go and do it again. We're trying to get some updates into it. Bug fixes and that. But effectively, you should treat it a bit as a toy, maybe as a sign of what we could build as a product. But the fact that this thing is out there doesn't actually commit us to building a product. So yeah,
you're killing me a little bit, Andre. Every time I ask you a question, you answer like the one right after too that you didn't know I had prepared.
No, I didn't.
I'm still going to ask you some of these ones that I had here. Alessandro, I know you want to say something. I just want to comment on this real quick.
And yeah, sorry for rambling, by the way. I know.
Here's the link. No, you're. This is awesome. So, I mean, I hope this is the right link, Andre. This is the where you can go, flings.vmware.com/ESXi.
There's also the blog site, by the way. Is it blogs? Let me just tell you what it is.
We can get that shared. And of course, this will all be in the description below. But for those of you who are interested in diving deeper, right, going into this ESXi on ARM Fling from VMware, definitely screenshot right now and go check it out after the show. Sorry, Alessandro, go ahead.
No, I was just going to ask about. So you mentioned that this is a preview to a product that you could be building if there is enough interest from the community, right?
Sure.
So I'm curious, in your, I guess, given your experience, given having done things like this in the past, what does it take if you find that there is enough interest from the community? What would it take to actually build this in terms of like time, right? Are we talking about 10 years? Are we talking about a year? Are we talking about 3 months? Like, what is the
That's actually a good question. It really is. I mean, so what I can tell you is that the way that we ran this project internally was that we were always aiming for code that was shippable, right? So it's not as if like, okay, well, we hack something out together, and God knows if you ever want to productize it, I would, good luck with that. Yeah, no. So we actually were in fact adding ARM support to ESXi was done basically into the same code base that we ship ESXi with on x86. And that's actually one of the immediate outcomes, is that this work has actually improved the overall quality of the code and made ESXi a better operating system, even on an x86. In terms of timelines, it's hard to comment onto that because, again, it sort of depends on the product definition. It really does, right? And I have ideas like, if we ever productize ESXi ARM at the edge, what would that actually look like? It might not necessarily look like our hypervisor today in the data center. Okay, you think that would probably have an impact on the timelines? It would, but it wouldn't have nothing to do with the base technology, right? Probably more so with answering like what does it actually mean to manage millions of systems around the world, right? But again, so I'd be very open with you, right? I have never shipped a product at VMware. All right, like never. So, well, again, I'm pretty happy to say that we put the Fling out there, right? And in many ways, it's an amazing effort for the small ESX and ARM team to. It almost looks like we duplicate this entire company shipping the same hypervisor on x86, although of course it's not really true, but still. But where was I going with this?
Reel you in.
Yeah, you reel me in. No, so you're asking about so timelines. It's very hard to comment on timelines.
I guess one thing I'll add then is if we get people on this call or people are listening in really interested, how do they push you to actually develop?
Okay, so that's where I was going with. So it's not as if we have this like big sign, an LED sign that just keeps counting up. Like, okay, look, if we cross this barrier, that's definitely going to be a product. So we are primarily interested, of course, by net new, basically kind of markets, kind of workloads. So this is why the edge is interesting to us. This is why this IO disaggregation story is interesting to us. And if this story is successful, by the way, this would actually mean like having way more ARM infrastructure in any data center than you see today. That's kind of cool. Really, it would have to be driven by net new workloads. Yeah, again, this is more of a product management conversation. Now, I've worn that hat when this project was in incubation, but at this point, I'm very happy to see that hat to actual product managers that know how to do their job. So,
thank you for being open and answering that question.
So if we can, I want to be conscious here. We have 23 minutes left in the broadcast. I want to dive into developers. Okay, so we've talked about now we've built this foundation: VMware, ESXi and ARM, the Fling. Developers. This is a pretty big paradigm shift, I think. Looking at traditionally what's been happening, and now all this going on ARM. So we've kind of talked about what this means for developers. Could you kind of shine some light on what this means for developers a little bit, I guess a little more?
That's a good question, actually, right? What does it mean for developers? So there's a couple of ways we could start talking about this, because there is the more immediate what it could potentially mean for VMware developers, VMware users. There's the angle of what it could potentially mean for people in the ARM community, and there's also but that what they could build on top of this. And the third aspect is, well, just that what are some of the other outcomes of ESXi and ARM existing in general? What that has affected? What else has that affected in the ecosystem? So in the first question is, let's say in our customer base, we do have people who are interested in evaluating ESXi ARM for a number of reasons. Maybe they're building mobile apps and they really would like to start testing these mobile apps internally, right? or they are evaluating some of these new ARM clouds. But again, they would like to do so first internally. Actually, it's funny, the development aspect is still pretty big. Like most of the reasons why people want to use virtualization on, let's say, servers in the data centers is like Android development. That's a huge one that I've heard. Now, it's hard to scale that, really, right? As a team kind of working on this technology, right? We can't support everybody. So one of the reasons why the Fling is out there is that, okay, well, you don't have to funnel things through us anymore. We don't have to give like separate builds out to people. Here you go. We have something that is validated. It runs on modern hardware, that we're willing to support. Flings that aren't supported, but within the confines of the Fling program. And anybody can go and get it, and then they can do their own POCs or whatever. And once they're ready to communicate something concrete to VMware, like, look, you have got it. You got to productize this. We're going to buy so many licenses of this stuff. We definitely want it. They can go do that, right? But what happened in the past, though, is a lot of things kind of stall on the POC phase where we get spread very thin, like supporting everybody. Okay, so the Fling really helps with that. It allows our customers to not depend on us to go and try their POCs using ESX and ARM tech. Now, what it could do for people that don't have anything to do with VMware, the FreeBSD example, I think, is one that I didn't expect. Maybe maybe it's something that other people find useful. Is well, here's a nice, easy way of running VMs. Some VMs. We don't have like some fantastic kind of compatibility store. We don't support Windows today, for example, right? But if you wanted to run Linux or even NetBSD or FreeBSD, our VMs in the tech preview are good enough, and you got this. Two ways of using it. One is this basic, host UI. It's like a web UI for a single box, and still, you got remote control of remote management of these VMs. The FreeBSD person, for example, he specifically called out saying that, look, I can access this thing from anywhere in the world, right? I don't have to like power cycle my Raspberry Pi. I don't have to have this thing on my desk. It was a powerful concept for him. And what was his name? Robert, I think. Sorry, I'm pretty bad with names.
What's it mean? Oh, sorry. Keep going.
Yeah, no. So from that perspective, the fact you have another hypervisor, you have another choice. It does get people interested in ARM infrastructure. It does get people, and maybe they don't like ESXi and ARM. Fine, right? There's plenty of other options, and product grade options. Great. So maybe this means more adoption of KVM or Zen for that matter. Fine, right? Nevertheless, now people become more aware that virtualization is a tool, and they can use virtualization to actually solve some of the problems that servers. You can run bare metal OSs in servers and have this remote access serial over LAN or this graphics console over LAN. With Raspberry Pi-like devices, you can't. But if you put a hypervisor there, I don't care whose hypervisor you're putting on there. Now you have remote access. Now you have decoupled your workload from the hardware. If the thing crashes, you can recover it. Or if you want to do an upgrade to the workload, you can checkpoint, save a snapshot, do the update. Oh, it didn't work. It ate itself. Great. Restore the check. And that's a part. These are simple, dumb VM tricks, but I think people are going to see the light that in this kind of smaller infrastructure, these are powerful concepts that can be used. Virtualization is not about consolidation. It really isn't, especially when you look at these like smaller devices. It's not about running 10 VMs or 20 VMs. If you can run more VMs, that's great. That's what you need. But the fact is, it's an out-of-band management of the workload, isolation of the workload, decoupling away from the hardware. Decoupling is not always good, but for many workloads, yeah, please decouple it. So that's kind of the second aspect. The third aspect is, in order for us to get the Fling out there, we had to solve our problem of what you or our customers could run the Fling on. And if the answer involved just buy an ARM server, that's a bad answer, right? We all know that, first of all, servers are expensive. Two, the servers are still hard to get. So there's a very high barrier to entry there. So it seemed like in order for the Fling to be successful, and by successful I mean to reach as much of our target audience as possible, without making them like commit actual money into it, it had to run on the kind of ARM infrastructure that anybody can go and buy in terms of volume, in terms of pricing, in terms of the ease of deployment, like it's on your desk, not in the lab somewhere. And so when we talk about ESXi back in 2018 on ARM, right? So, like, well, publicly, visibly, it wasn't very visible what was going on. The VMware just stopped talking about it. Like, you guys have been working on anything, right? Is the edge and ARM story dead? What we were working on in the background is trying to solve this problem of like, well, there's no actual edge hardware out there. There's no small hardware. So I'm really happy that, one very immediate outcome of this is that ARM launched the system-ready ES, or embedded server, set of specifications. Well, first of all, launched the system-ready umbrella of specifications.
Awesome announcement.
Took the server-ready specs, it broadened them. The server-ready specs are still there. They're just called system-ready SR, but the ES ones basically capture, in my opinion, like 95% of the value proposition behind server-ready, right? In a way that still allows silicon or companies or OEMs to build hardware without incurring the pain of that last 5 to 10% of actual server compliance. So you can build systems that are not servers and yet exhibit most of the properties that we want to see. And it's kind of a no-brainer because, hey, the other architecture, x86, do they have non-server systems? Check, right? Do those systems boot and behave just like servers, even though they may not have ECC RAM or something else? Yeah, it's a no-brainer, right? So system-ready ES, I think, is bridging. It's kind of broadened. It's broadening the pool of standards-compatible ARM systems, which is, I think, very important. Because again, my opinion is that ARM could do servers because it was wildly successful in the mobile ecosystem space, obviously, right? But in doing servers, kind of the way it should have been done, great, fantastic. It's close to the x86 ecosystem, but I would call this a Grand Canyon. It's like you have one ecosystem here that was a mobile ecosystem, and then there's a server ecosystem, but they don't touch in any meaningful way unless you're running Linux and running applications there, which is great, by the way. But it doesn't, there's no developer systems. There's no, like they don't really touch. These ecosystems were not really touching each other. Which again, this does not parallel the success of what Intel did with x86, because by the time Intel was building a server, right, they already had captured the entire kind of home computer and business computer market. So with ARM, it was almost like the inverse story. Like you could do servers, great, and now we need to extend it out to these systems that are still within the same compatibility kind of. They're still compatible, but then they're not servers. And system-ready ES was this, I think it's a major step. Now, I think I can say this. I've actually validated this with the technical colleagues at ARM, is that system-ready ES wouldn't actually exist if it were not for this collaboration that VMware and ARM did with the Italian core community in developing the Raspberry Pi 4 UE5. That actually led to system-ready ES. That's why the Pi 4 is the first system-ready ES certified system. So you can say that, well, yeah, great. That's why we can do the Fling, right? But it's much bigger than that, right? It's I think the fact that now you can boot Windows on the Raspberry Pi 4. Microsoft has talked about system-ready ES. They've endorsed it. Other OS vendors have endorsed it. It's the way forward, right? So I think from an ecosystem perspective, that's a much bigger outcome than running ESXi and ARM on any system, including the Pi 4.
And Andre, you did. I mean, I remember following you during all of this effort with this website that we just posted their launch. You did a tremendous amount of work here with a bunch of people, of course, giving credit to everyone. You did a lot of work here, and I mean, I think credit where credit is due. It's awesome. I mean, I think you're very accurate in stating what you've just said. It's been a lot of.
Thank you. I mean, as you mentioned, it's actually there's a lot of effort going on, and there's quite a few people I'd like to kind of single out, both in the ARM and Italian core communities, that made this a success. But by the way, the website is not dead, even though yes, it deserves an update. Yeah. Well, we'll get right onto that. The website should actually talk about system-ready ES now, because that is exactly what the Raspberry Pi 4 is. The site is called Making Pi Server Ready. Well, yeah, sure. It's actually system-ready ES now. We can now come out and say what it is. So, yeah.
Thank you for that. That was really interesting. I remember being on one of the first calls in which we talked about, even though I wasn't really involved, but I got pulled into this call when we talked about making Raspberry Pi server ready. At the time, it was, we were talking about server ready, and I was like, this is gonna take years, and then we're here like probably I don't know, like it's been maybe, I remember some conversations a year, yeah, well maybe.
I mean, I started
even less than that probably.
I started at ARM last October, and I mean, this page launched after I had started at ARM. So I'm sure you were doing work behind the scenes, Andre, for a long time with a bunch of people. But yeah,
I think the page, I started working on the page, I think it was like December or January. It was either, I think it was out of a conversation I had with you that, that's why I started working on this page, kind of to put all these ideas together and to use this as basically a storefront, really, right? To show people that, I have a whole page there of why standards are important for basically non-server systems. But I guess never underestimate the power of, small motivated groups. And there's a lot of people in the ARM community that are interested in making this happen. So my current commitments really don't allow me to spend too much time, unfortunately, on the UEFI stuff. Even though I have a whole bunch of items that I'm still on track that I got to go fix, my little fixes. And of course, we are working on SIEM4 support, and actually the way that we're tackling SIEM4 support is going to be another. I don't want to spill any beans, but again, I think people will appreciate how it's done. And I think it's more than the Pi story. It's actually going to help a lot of other platforms as well. The Pi 400, Raspberry Pi 400 is out. Yeah, that one still doesn't work either. I don't have one. I don't know if any of my partners in crime do, but yeah, we will get support for that eventually as well, of course.
I want one of those RPi 400s. I think it's just an amazing thing that they did.
Yeah, and by the way, I'll have to say that yes, I talk about system ready ES and Raspberry Pi 4s and how the hardware is now close enough that it can be compliant. But you know what? You can go get a Raspberry Pi 3 A+, or what is it, $25 now?
Yeah, well, in A, yeah, easy.
Yeah.
I mean, the ones are 35 or something. So
exactly, so it's dirt cheap, and you can actually have UEFI on that. I mean, the ACPI is kind of sketchy. It's not really ACPI, right? Because again, the Pi 3 but if you use it in this system ready IR, IoT ready EBBR device tree way, you still get EFI, you still get Pixie booting, you still get even the ability to boot Linux from an iSCSI box. That's huge. It really is, right? So even with a Raspberry Pi 3, even though you don't have ACPI, fine, it still just pushes the platform out so far compared to where it was before, in my opinion, at least. I know other folks in the community, like David Tischler, have specific pain points around deploying operating systems on small IoT boards, and UEFI, even with device tree, actually solves many of those.
You just touched on an interesting point. So we talked about system ready as a class of kind of certifications, right? And there is different bands, and you just touched on another band, IoT ready, as well as obviously we just mentioned the embedded server ready. So I was going to ask you, I mean, you kind of mentioned it slightly in passing. So what, from your perspective, what does it mean to be in a band or another? Like from a developer perspective, right? Like that's what I'm really curious about is what does it matter from a developer perspective to work on these platforms in these different bands?
Yeah, so this is an interesting and heavily opinionated topic. Obviously, a few years back, it was like the device tree versus ACPI, flame war, I guess. I think it's a good way of calling it. And I'll be honest with you, I think, and I certainly contributed to the damage, right? It's like, because honestly, everybody took these very kind of hardline positions, but with ACPI, so what problems does ACPI solve? Well, you can boot an operating system far enough that to recognize you should load some extra drivers. That's what ACPI gives you. ACPI and device tree are inherently very similar. The difference is because of the bytecode component to ACPI, this interpreted language part of it, is device tree is not a static device tree, but it's written in this bytecode. And really, every time you get a property, you're calling a method that can go do something. That provides a level of decoupling where you can change the hardware a little bit, right, without affecting the software. Or to look at it a different way, you can't paint yourself in a corner too much. Like, okay, well, you screw something up. Well, okay, you can fix up some of these things up in the AML. Conceptually, with device tree, can you build like nice, well-compatible systems with device tree? I mean, yes, you could. Could you build systems that are wildly hard to support in any OS using ACPI? Yes, you can do that too. The Raspberry Pi 3 is a good example of a system that kind of uses ACPI, but it's such a pain, right? Well, it's not really ACPI, but it looks like ACPI. But but with device tree, it's most of the time when you talk about device tree, you're not talking about systems that are all kind of compatible with each other at a hardware level. And device tree doesn't really allow you to abstract. It's a great way of describing exactly what the hardware is. That is what device tree is. Unfortunately, that does mean that if you have a board, a kernel compiled with support for a particular board, your chances of even seeing any serial output on a different board is 0, right? And that is, I think, the best way of contrasting with ACPI. Right? With ACPI, yeah, you know what? If you have embedded devices, you still need drivers for those. Like, that's not going to go away, but you can boot far enough to load those drivers, okay, and have a single kind of binary distribution image. For developers, I mean, these are kind of two different worlds. There's the device tree world, there's the ACPI world. Well, the device tree world is very popular in practically everything today outside of servers. And by the way, I think device tree by itself is a great technology. My take on it is that it's the last marshalling format for any configuration that anybody should need. Like, everybody's bootloaders, builds their own data structures to hand to kernels and, using configuration files. And then at some point you run into like some limit where like, okay, the configuration format you came up with is not good enough anymore. Well, device tree is easy to parse, is infinitely flexible and hierarchical. So I think it's a great thing. ACPI was a pragmatic choice for servers, to be honest. I think it allows, it's just not that weird to people who build, like OEMs who build systems. And it does leave a little bit of breathing room for the hardware vendors, right? Where they can still screw something up, but you won't have to know about it.
Every time, Andre, that I have a conversation with you and I hear you talk, I just wish you were like my college professor, back when I was in school. Or I wish when we meet in person, Alessandra and I are going to sit down. We're going to have a few beers on us. And I mean, I just look forward to picking your brain on so many more things. But
I'm learning to be a little less opinionated about things.
It's just so great. I mean, it's just so great just sitting here listening and absorbing all of this stuff, because you just have so much knowledge on all these things. And I mean, of course, opinions, but still knowledge on your experience. So on that note, though, unfortunately, we do only have 3 minutes left to this call, and I do have to close it out. On behalf of ARM and Innovation Coffee, thank you, Andre, so much for your time. It's just been great. But we do want to give you at least a minute or two if you have a shameless plug, anything that you'd like to tell our viewers, the people.
Maybe just at least, because I didn't have a great demo for reasons, but I have a demo, so I can at least maybe just share my screen.
Oh, there's a demo. Okay, yeah, cool.
That's a good plug, right? A good last plug. You can't beat that.
Is this too small or no?
It's a little small. I was actually going to say it would be worth maybe doing a little separate stream. It might not have to be an Innovation Coffee, but maybe we could do another little surprise stream with you to do some more ESXi stuff.
Yes, but this is a Debian VM I'm installed. This is actually running on a Raspberry Pi 4 with 8 gigs of RAM, and this is the host, the embedded web host client of ESXi. So you don't need so this is This is just a web UI. This IP address that it gives you here. I just pop it into a web browser, and boom, that's the UI. You can create VMs and use them. So you don't need vCenter to go and access an ESXi and ARM host. I mean, if you have vCenter, which is our data center management plane, you can do that. But it's very easy to get going with just a single, Raspberry Pi and use it. This is a Debian VM. I'm not going to show you the installation for it, but that's kind of what it is, And yeah.
Okay, but I think the real question here is, can it run Doom?
Yes, it can. So people have definitely conclusively put that one to the rest. I think we can run Doom on Linux and in NetBSD. I've seen both now.
Wow.
Awesome. Very cool.
So what I love about this, so the people on the show probably don't realize that when we started, you'd said that you didn't have a demo, and I think you made it work while we were talking, while you were being interviewed. so big clap to you.
Literally, we were in the green room, and he's like, I don't have a demo today.
But the thing is, if I had a few Pis, I could show you live migration of a workload from one to another. I could show you fault tolerance, which like the VM is running on 2 Pis at the same time. It's not really running on 2 Pis at the same time, but it's like continuous checkpointing. But anyway, there's tons of cool stuff that I could show you. We do document this pretty well. So if you go to the Fling site, there's all these great documents there that tell you exactly how to install ESXi and ARM on different platforms. And we support the Pi, the Ampere eMag, the Salabron Honeycomb. We support some of the other like Layerscape 1046A based systems from NXP. If you have an N1 SDP from ARM, which I know is a hard one to get a hold of, but yes, that one is in the supported list as well.
Yeah, I was actually going to say, I was literally going to plug that for you if you didn't. So yes, definitely what Andre just said, go to that website down there. Will be in the description as well, but you can get the ISO, so you can literally download the ISO and you can get the documentation for all that stuff. One last plug for you, Andre. Make sure you go to Twitter, follow ESXi_ARM for all these cool ARM ESXi updates. And if you want to keep up to date with what Andre's up to, this is his handle, What Ain't Inside, at Twitter. I hope it's okay. I plug that one for you too.
Sure, thanks. Yeah. So,
awesome.
And by the way, yes, we have an HCL, and if something doesn't work there, let us know. But there's a few other systems that the Fling will work on that we don't really talk about because I guess it doesn't make any sense to talk about hardware that you can't really buy anymore. But the Macchiato bin, although it's fairly old, the Macchiato bin should work. The Overdrive 1000 should work. Kevin Thunder X system should work. You heard it.
Awesome. All right. Well, thank you all for watching. Andre, once again, thank you for your time. All the viewers on YouTube, thank you. Alessandro, I'm getting this wrong today. Over to you.
No, I mean, I really enjoyed, listening to you to talk today. I think I had a lot of questions. I still have a lot of questions, but you answered all the questions really well. And, I really appreciated your being open and being kind of, telling us what you know so far, what you've learned so far. So thank you so much again, Andre. And thank you everyone for watching. And with that, I think we can close off today's show.
Bye, everyone. Thanks, Andre. Bye.